Have you ever wondered about the universe, like how big it is, what it's made of, and how it all works? Yeah, me too! It turns out one guy had a really big idea about all that. His name was Albert Einstein, and his theory of relativity totally changed the way we see the cosmos. Now I know what you're thinking. Relativity? Sounds complicated, but trust me, it's not as scary as it sounds. In fact, it's actually pretty cool once you get the hang of it. And don't worry, I'm going to explain it all in a way that even your pet goldfish could understand. Einstein's big idea was that space and time aren't these rigid, unchanging things like we used to think. Nope, they're more like a giant, flexible sheet that can be bent and warped by things like gravity. Imagine a trampoline, right? If you put a bowling ball in the middle, it makes the fabric sag, creating a dip. That's kind of like what massive objects do to space-time. So buckle up, because we're about to embark on a wild ride through the mind-blowing world of Einstein's theory of relativity. First up, let's talk about special relativity. Don't worry, it's not that special, it's just that Einstein came up with it first. This part of the theory is all about how speed affects time and space. Here's the gist. Imagine you're on a train traveling really fast, like close to the speed of light fast, which is the fastest anything can go in the universe. Now, if you throw a ball forward on the train, it looks to you like it's going at a normal speed, right? But to someone standing on the ground, watching the train zoom by, the ball would appear to be moving much faster because it's got the speed of the train and the speed you threw it with combined. So far, so good. But here's where things get weird. Einstein realized that the speed of light is always constant, no matter what. It doesn't matter how fast you're moving, the speed of light is always the same. This whole speed of light is constant thing has some crazy implications. Because if the speed of light never changes, but speed affects time and space, then that means time and space themselves must be relative. Think about it this way, time slows down the faster you move. It's called time dilation. And it's not just a cool name for a sci-fi movie, it's a real thing. Now before you get any ideas about building a time machine, let me stop you right there. The amount of time dilation you experience at everyday speeds is so tiny, it's basically unnoticeable. To really see the effects of time dilation, you'd need to be traveling at a significant fraction of the speed of light. And trust me, our current technology is about as equipped to do that as a hamster is to pilot the space shuttle. Now, even though we can't zip around in time machines yet, time dilation has actually been proven experimentally. Scientists have flown atomic clocks in jets around the world and compared them to clocks on the ground. Guess what? The clocks that flew through the air actually ticked a tiny bit slower than the ones on the ground. It's true, time is relative. This means that time is not a straight line that everyone experiences at the same rate. It's more like a river that flows at different speeds depending on where you are and how fast you're moving. Pretty wild, huh? Section 5. General relativity gravity gets real. Okay, so that was special relativity in a nutshell. Now let's move on to general relativity, which is where things get really interesting. This part of the theory deals with gravity. See, Einstein realized that gravity isn't just a force like Sir Isaac Newton thought. Instead, it's all about the curvature of space-time. Remember that trampoline analogy? Well, massive objects like stars and planets are like those bowling balls, warping the fabric of space-time around them. Section 6. Space-time twisters, black holes, and other cosmic oddities. And the more massive the object, the more extreme the warp. In fact, if you cram enough mass into a small enough space, you can create a black hole, a region of space-time so warped that nothing, not even light, can escape its gravitational pull. Black holes are like giant, cosmic vacuum cleaners, sucking up anything that gets too close. They're also some of the most mysterious and fascinating objects in the universe. And thanks to Einstein's theory of relativity, we can begin to understand how they work. Section 7. Relativity in your pocket, GPS, and the fabric of space. But general relativity isn't just about explaining weird things like black holes. It also has practical applications here on Earth. Ever use GPS to find your way around? You know, that thing in your phone that tells you where you are and how to get to the nearest taco stand? Well, guess what? GPS relies on Einstein's theory to work. You see, GPS satellites orbit Earth at super high speeds. And because of time dilation, remember that? Their clocks run a tiny bit slower than clocks on the ground. Now that tiny difference might not seem like a big deal, but if you're trying to pinpoint your location on Earth with meter accuracy, it's huge. So GPS satellites have to adjust their clocks ever so slightly to account for the effects of relativity. Section 8, Einstein's Legacy, a Universe of Possibilities. So there you have it, Einstein's Theory of Relativity in a nutshell, or a spacesuit if you prefer. It's a mind-blowing theory that has revolutionized our understanding of the universe and our place in it. Einstein's work has had a profound impact on everything from cosmology and astrophysics to technology and our everyday lives. And as we continue to explore the cosmos, his theories will continue to guide us, helping us to unravel the mysteries of the universe and unlock its secrets. Section 9. Keep exploring. The adventure continues. The universe is a vast and mysterious place, and we're only just beginning to scratch the surface of its secrets. But thanks to brilliant minds like Albert Einstein, we have the tools and the knowledge to keep exploring, to keep asking questions, and to keep pushing the boundaries of what we know. So, the next time you look up at the stars, remember that you're looking at a universe shaped by relativity. A universe where time and space are fluid, where gravity warps the fabric of reality, and where black holes lurk in the shadows. It's a universe full of wonder, mystery, and endless possibilities. And it's all out there waiting to be explored.